In ancient times, humans like us were scared when they discovered a chemical reaction between a fuel and the oxygen in the air, giving rise to the word combustion and the discovery of fire. Shortly after, until 7000 BC, it was when humans perfected techniques to make utensils that produced friction. During the age of metals, they took advantage of fire and the materials that nature gave them, and one of the first chemical phenomena was achieved: metal alloys. With fire and strength, they made bronze and iron tools to defend themselves against animals. Then alchemy arose, whose main objective was to discover a substance that could transmute ordinary metals into gold and silver, that is, to discover the elixir of immortality. Therefore, alchemists are considered the first chemists. Alchemy has roots in Egypt and China, from the 4th century BC to the 8th century. During the Han Dynasty, alchemy mainly focused on the search for immortality and the elixir of life. Thanks to ancient China and its great discoveries, it was the invention of gunpowder, a mixture of sulfur garbage and potassium nitrate that revolutionized war and hunting, as they believed that gunpowder helped drive away evil spirits and attract good luck and prosperity. Gunpowder was also used as a military tool to make weapons, and they created the compass that allowed sailors to orient themselves at sea. As we know, the first manifestations of chemistry began with the Egyptians, Chinese, and Babylonians, with the preparation of food and the handling of metals, giving rise to Thales of Miletus, who studied the composition of matter, and then to Aristotle, continuing with the theory of the four elements. Later, Leucippus and Democritus claimed that matter was composed of tiny particles called atoms. And finally, by the 17th century, Antoine Lavoisier laid the foundation of modern chemistry with the law of conservation of matter with the famous phrase, "Matter is neither creator nor destroyer, it is only transformed."
Niels Bohr proposed the structure of the atom in which electrons were located in energy levels. Dmitry Mendeleev organized the periodic table of the elements based on their atomic weights. In the 20th century, Albert Einstein expounded the theory of relativity. Pierre and Marie Curie studied the radioactivity and discovered the new elements, polonium and radium. At the end of this century, with the studies of the DNA molecule causing the cloning of living. Concept of chemistry is the branch of the science that is responsible for the studying of characteristics of matter as well as change it undergoes. The scientific approach to problem solving. Number 1. Recognize and state the problem. In this stage, data in addition to observation are collected and analyzed. Number 2. Proposing solutions to the problem and explain. This stage is called hypothesis formulation when the relationship between two or more variables is provisional predicted. Number 3. Determine the best solution through tests and experiments. This stage is characterized by experimentation based on the information collected or the search for new information.
Hello, I am Jose David Sanchez Garcia, and I'm going to explain how chemistry connects with other science. Chemistry is considered the central science, since it is related to many of the other sciences and has a very important role in all of them. It may be creating compounds or mathematical operations, among others. Some of the most important contributions are the following: mathematics with operation for formulas, physics with some laws of chemistry, biology with the structure of living beings, agriculture with fertilizers, engineering with the creation of materials, and medicine with compounds of medications. There are many more sciences, such as astronomy with the creation of the universe, among others. Thank you for your time.
Classification of matter. Everything is made up of matter. Matter is everything that occupies a place in space, has mass, and classified according to the components and their properties. Matter is classified in different ways: pure substance and mixtures. A pure substance is a form of matter from which things are constituted. It has a fixed and constant composition. Pure substances are divided into elements and compounds. Elements are a simplest form of matter, impossible to decompose because the atom is the smallest particle that retains the element properties. Compounds. These substances are formed by combining two or more elements in a certain proportion. Chemical processes can decompose these. Mixtures is the matter where two or more pure substances come together which are combined physically. There are two types of mixtures which are homogeneous and heterogeneous. Their composition is uniform. The phase that constitute them cannot be distinguished, and heterogeneous. They lack a uniform composition. Their properties vary and consist of two or more distinct physical phases.
General properties. Matter has properties that make it possible to distinguish the material from the non-material. These general properties are mass, amount of matter contained in a body; volume, measurement of the space occupied by a body; weight, force exerted by gravity on a body; inertia, property that matter presents is based on the resistance that bodies present to change their state of rest or movement concerning a reference point; impenetrability, property of matter that prevents two bodies from occupying the same space at the same time; and porosity, characteristic of matter as it has empty space known as pores. Specific properties. They are the characteristics that each substance possesses which make it possible to distinguish one from another. Physical properties are the characteristics that can be observed. For example, state, smell, color, flavor, density, viscosity, malleability, melting point, boiling point, and volume. Chemical properties. They refer to the ability of matter to create new substance by determining their behavior when they come into contact with others. For example, combustion, oxidation, reduction, corrosion, and chemical stability.
The chunks in a matter. The physical chunks. They are chunks of matter that do not imply an alteration in the internal structure of the substances, only its shape is affected. One characteristic that these have is that there is the possibility of them passing from one state of matter to another when a change in temperature or pressure is applied. Reaction states are six. The first one is a fusion. In the fusion, the matter transforms from solid to liquid when the temperature increases. The solidification. When the temperature of a liquid substance decreases, it transforms into a solid. Evaporation. The transformation from liquid to gas occurs as the temperature increases. The condensation. The gas transforms into a liquid as the temperature drops. Sublimation. The solid turns into a gas if the temperature and pressure are increased. Deposition. It transforms from gas to solid without passing through the liquid state through a sharp decrease in the temperature.